Part 2 of 3.4. Some fun algebra ness here. All right, so we're talking about radical equations. So very similar to the rational expressions we're solving for x. Yeah, that's when the equation is you're solving for something. So what makes these radical equation is, guess what? There's a radical in our problem. Now to get rid of radicals, well, we talked about this before. To get rid of a radical, you have to square that whole side. When we square this side, it cancels out this radical. Now, but what you do to one side, we have to do to the other side. So that's what we're doing here. We're practicing this. So when we square this side right here, we square this side and we square this over here, the radicals cancel each other out, leaving me just the 3x plus 1. Over here, when we square the 4, we get 16. And the rest is just very simple. We solve for x. So we minus 1, 3x equals 15, divided by 3, divided by 3, x equals 5. Okay, it's kind of a simple one here to kind of start us out. So kind of get the idea in this case, that's what we're doing. So let's practice a couple more that you'll see throughout the homework. So here, it's a double radical on two sides. So let's go ahead and square, same thing. So we'll square this side, and we'll square this side. Again, when that happens, when you square something with a radical, it gets rid of the radical, leaving us 4k minus 2 equals 3k plus 1. All right, so now the rest is just solving for k here. So we'll subtract 3k. We subtract the smaller side to the bigger side, canceling, giving us just k minus 2 equals 1. And then we'll add 2 to both sides, plus 2. K equals 3 in that case. Pretty simple, right? Let's look at some other ones. Keep going. So you'll run into something like this right here, where on one side there's a radical, on the other side the other one. But now, unlike the first one where it's just one term, there's two terms. So same idea here. We're going to square this side, and we're going to square this side. Now, when you square something with the radical, like always, it gets rid of the radical, leaving us just the m minus 2. I'm going to put it right to the side. But when you square this, you're saying m minus 2 squared. It means that is saying m minus 2 times m minus 2. So we're going to have to FOIL this out right here. So let's kind of practice that. So m minus 2, you want to go aside? Hold on. Give you guys a second. Here you go. Go. Sorry about that. All right. So when we square both sides, on one side, you just get your m minus 2, the side with the radical. This side, we square that. We FOIL that out. So m times m squared, n times 2 is negative 2m. Negative 2 times m is negative 2m. And negative 2 times negative 2 is positive 4. Combined like terms, we end up getting m squared minus 4m plus 4. All right. So since we have a square, more than likely we're going to have to kind of factor that out. But let's go ahead and move everything. So we're going to move everything on one side. So we're going to subtract m minus m and add 2 plus 2. So we're left with just 0. 0 equals m squared minus 5m plus 6. So we're left with a quadratic. Now, we worked on this on the last section, the 3.2, where you either do completing the square, you can do the quadratic formula. I'm going to just FOIL this out because it should FOIL out nicely. So let's check that out, see if it does. So I'm saying, so 0 equals, so what times what gives me m squared? M times m. What times what multiplies to be negative 6, but they add up to be a negative 5? Well, a negative 2 is a negative 3. So n minus 2 and n minus 3. Negative 2 times negative 3 is a positive 6. Negative 2 plus negative 3 is negative 5. So then when you're left with this, 0 equals these two binomials right here. We separate it. We'll say, all right, so 0. So 0 equals m minus 2, and 0 equals m minus 3. Add 2, 2 equals m, and plus 3, 3 equals m. So these are our two answers. We have two answers for this problem right here. All right, let's try one more. This is probably as hard as might get right here.